Hello everyone, welcome back to my channel, and today is day 23 of 100 days of DevOps. So if you're seeing my video for the first time, what we are trying to achieve is we are trying to cover everything about DevOps in 100 days, and we just concluded the phase 1 of this journey. That was 2 days ago, where we talked about fundamentals. We talked about understanding Linux. We talked about networking. We did a networking project. We also covered version control. We covered YAML, and we discussed extensively on web server Nginx, to be precise. And yesterday we got into the second phase of this journey, which is understanding containers and CI/CD. I took the time to explain everything about containers, the life cycle and the architecture of Docker yesterday. And if you've not seen that video, I would advise that you check it out. It's happens to be a very interesting section, something that you will really benefit from. So today we're going to continue with that progression, and if this actually sounds like something that it resonates with you and it's something that you're interested in, please do well to see the previous video, like the videos. You can share it with anybody who is also interested or who you want to also get on board in learning DevOps Cloud or tech in general, because that's what this channel is all about. Then also do not forget to subscribe to the channel, and most importantly, turn on your notification bells so that whenever I post a new content, you get it immediately. Then you can watch it and then add to the knowledge that you already have. So that said, we're going to go to what we want to do today. So yesterday, like I said, I spent a lot of time explaining containers, why there's need for containers, talking about, we took it back to the days of running our applications on bare metal, and then we discussed the challenges that brought about, and then we also talked about virtualization, and then from there we also now moved to container, because we concluded that the containers are born out of virtualization, and virtualization were actually born out of running the applications on bare metal. So we actually did that. We covered that extensively yesterday. Then we went to Docker. We talked about Docker because I said we're going to be focusing on Docker for this particular part of this session. So we talked about Docker. We got to understand what Docker really is, Docker life cycle, and we talked about the architecture of Docker. So we are going to go today. Today we are majorly going to be working on the terminal. There will not be any theoretical work. Yes, yesterday when I covered Docker architecture, I mentioned some commands like docker pull, docker build, docker run, docker push, and apart from these 4, there are lots of other commands. So we are going to see how all of this works real time. Since we've done all the whole theoretical talks yesterday, we are going to start getting our hands dirty immediately. So we are going to go to our terminal, and I would introduce you to other commands that will be very, very useful to you. So let's go straight to our terminal. So this is my VM, and as always, we should always confirm who we are and our present working directory so that we'll know where we are working from. So we installed Docker yesterday on our VM. If you haven't installed Docker yet on your virtual machine, you can make reference to yesterday's video, and then we did it step by step, and we were able to install Docker. So one thing I noticed yesterday was that, okay, before that, let me show you. To check, there's a command to check we're able to pull an image and a hello world image yesterday. We couldn't finish that of the Nginx because it was taking time, so I had to, stop it. We're going to do that today. But before then, we were able to pull the hello world image. So if I want to, there's a command for you to list all your images, to see the images that you have on your host. There's a command to do that. So when I do Docker images, but first of all, before we do that, we need to confirm that the Docker recent is running. Status Docker. So we can see that it's active and it's running, because sometimes there might be some situations where you would try to execute Docker commands and they would not be working. One of the things that you can check, it's also part of troubleshooting, check if the system, the service is actually running. So we need to confirm that the service is running, which we have done now. So to check the images that you have on your host, the command for that is docker images. So, but now I'm getting a blocker, permission denied, we're trying to connect, blah, 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 and all of that. The reason why we're having this this challenge is because if I use sudo docker images, we'll see that we can see the image. Like I said, we put the hello world image yesterday. But most times we don't want to always work with sudo because it can really be stressful. So what happens is that when you install Docker on your virtual machine, Docker automatically creates a group named Docker. So we can do that by checking /etc/group. So if you come down, you'll see it here. This was yesterday, it was created yesterday. So this is a group, this is the Docker group. So what we need to do is that we just, for you to not run sudo anytime you want to run your Docker command, it's better for you to add the user to the Docker group. So by the time you add the user to the Docker group, you are going to be able to, run commands without having to use the sudo all the time. So how do you do that? You do sudo user add -ag. So you're adding it to, which group are we adding to? Docker. And what is the user? The user is detached. So when I click on this, it's saying, it is giving invalid. Let me see. It's supposed to. Is it user add? All right, I made a mistake. The command is user mode, not user add. Sorry, my bad. So when you do that, you can see that we didn't get any error response. So let's confirm if we have our user as part of the Docker. So we have our user as part of the Docker group. So let's see if we can run our command. Let's see, Docker images. So we are still getting that permission denied message. Why is this? That's because when you add a user to the Docker group, you need to restart your system. You need to restart your VM for that change to make effect. So let's see. I've not done this. I've not tried this before, but let's see if it's going to work. If I restart the service, let me see if it's going to work. So let's see. So we're still getting that permission denied. So what I'm going to do is that I'm going to restart my VM, my virtual machine, and then once we come back, we'll test the command and see if it's working. So I'm just going to do that by typing, there's a command sudo init 6, there's init 0, init 1, init 2, init 3, 4, 5, I think 6. Yes, so 0 means if you're using, most of the commands that we use for init is 0 and 6. 0 basically is to shut down your VM. So if you see somebody say init 0, it means that the person is trying to shut down their VM. And if you're doing init 6, you're trying to reboot your VM. So when I click on this, I will get a message, system will reboot now. So let's give it a while. I'll be back once the system has rebooted. Okay, so we are back and this system has been rebooted. So let's confirm that our Docker service is running. Okay, so let's now try to run the command. Good. So now we can run our command without having to use the sudo privilege. So it reduces a lot of stress for us. So the first command that I'm introducing you to is Docker images. Basically, this command lists all the images that you have in your host. So all of the images that you have pulled from your Docker repository, from your Docker repository or Docker hub to your Docker host will be shown by this particular command. So let's now pull an image. So before that, I want to show us the Docker Hub. So let's go to hub.docker.com. So this is how Docker Hub looks like. And basically, Docker Hub is the repository where Docker stores all its images. So if you scroll down, you can see the Postgres image, MySQL image, MongoDB image, Nginx image, Node, Golang, PHP. So you can always come here to make reference to any of the images that you want. And then there's also the search bar where you can search for an image. So we are going to want to pull Nginx image. So we would click on Nginx. So you can see okay, so you can see the name of the image, Nginx. You can see the tags that is supported. Basically, it's like let's say tags are like different versions of the image. So yes, tags are like different versions of the image. So you might not want to pull maybe the Nginx, normal Nginx image, and you want to, depending on your application, it might say, okay, you want an Alpine version of the Nginx image, which is a light weight version, or you want an open telemetry version of an image. So you always go here, you search for that particular image, and then you use the command docker, pull. So now that I've shown us how Docker looks like. So Docker Hub looks like. Let's go to our terminal. Let's pull an Nginx image. So we'll do docker pull Nginx. So docker pull is the command that gets your Nginx, your image, whatever image you want to pull. You use docker pull and then the name of the image. So it checks your local repository or your Docker host to see if the image is there. So if the image is not there, then it goes out to your Docker repository, that's your Docker Hub, gets the image and brings it to your Docker host. I explained this yesterday when I talked about the architecture of Docker. So you pull an image and then you bring it to your Docker host and then you're able to run that image. So I'm just going to give it a few seconds, a few minutes for the image to finish pulling. Then we can proceed with what we want to achieve with this. All right, so our Nginx image has been successfully pulled. So now that we've pulled our image, so we have our image on our Docker host. So if I do Docker images, so you can see now that we have Nginx image, you can see the tag, which is the latest. If you don't specify any tag, Docker will pull the latest image, the latest version of the image by default. So now we have Nginx. So what we'll do next is that next command I want to introduce us to now is docker run. So docker run, I want to run Nginx. So when I run this command, it's going to run, but now it's not, how do I put it? I don't have my terminal back. I can't do anything like this because it's running. So what I need to do is that there's a way you can run your images in the background. So for me to be able to, this is actually good if you want to see live activities that is going on with your container. Then you run it on one terminal and then you can monitor it. Then you have another terminal which you can use to do other commands and the rest. But say you want to use just this terminal, you can always there's a way to run this command in a detached mode so that you are able to get your prompt back to type your command. And then secondly, if you're running Nginx, you need to map it to, there's something called, okay, when I covered Nginx on day 21, I made mention that Nginx default port is port 80. That's, this container is running on port 80. So by default, Docker does not expose your containers to the public. So if you want your containers to be exposed to the public, you need to map it to a port. So what I'm going to show you now, I'm going to show you how to run Nginx in a detached mode, then how to map the container port to your host port so you can access this particular container on your browser. So I'm just going to come out of this. So I will do, it's still the same Docker run, but at the same time, I'm going to add some flags. So -d means run this container in a detached mode. Then -p is your mapping. Which port do you want to map with the container port. That's your host port. So I'm going to map port 8080 and I'll map it to the container port, which is Nginx default port of port 80. So I don't know if that is clear. Basically, -d runs your container in a detached mode. It runs it in the background. So you can be able to see what your running containers. When I show you the next command will be to list your running containers. So while -p maps your host port to a container port. That's basically what we're trying to do, because like I said, by default, Docker does not expose your containers to the general public. So for you to be able to expose it, you need to map it to a port on your host. So, and I'm mapping to port 8080. So when I run this command, I'm only going to get the ID of this particular process. So now, how do I see if a container is running? The next command is docker ps. Docker ps basically lists running containers. So you can see that it is running. So you can see that the first numbers are the same thing and the image is Nginx. You can see it was created 15 seconds ago, and you can see that it is port 8080 mapped to port 80. So if I go to my browser, and I type my IP address, so 136, and I do port 8080, I'm supposed to get Nginx. So you can see, welcome to Nginx. So you can see that we can access the Nginx because I have mapped it to port 8080. So now that is how you map a port on the host to a port on the container. I've also covered how you can run a container in a detached mode. So the next thing is there's another command, which is docker ps -a. This -a flag, basically it just lists all the previous, as long as you've previously run a process. You have it like it's hidden. So -a would bring out all of the previously run process. So, and one thing you should know is that if you don't delete this Nginx, all of these processes, you can't delete an Nginx image. You can't delete the image. If a process is still either running or you've run that process before, you can't delete that image. So that is the way it works. So for you to be able to delete the Nginx image from your Docker host, you have to make sure that you've removed every process that has previously or currently been used of that particular image. So now I've been able to cover Docker image, Docker pull, Docker run, Docker ps. So I want to, now we have a running image. I want to inspect that image. So I'm going to use the command docker inspect, and I can just use the container ID. And if I do that, you can see the configurations of, you can see host IP is port 8080. You can see the gateway is, the local host. And basically you can use this when you need to troubleshoot. When you want to troubleshoot, you can see the command that runs this process. Nginx-g daemon off. That's the command that runs this process. You can see the name. You can see that it doesn't have any volume. You can see the entry point. We're going to talk about this tomorrow when we start writing our Docker file. We see entry point. You see we have CMD. We have entry point. We're going to look at the two of them. We're going to see the difference. Then we're also going to talk about ports, the exposed port. You can see that the port is 80. So we are mapping port 8080. This is the host port, and then this is the container port. So we are mapping port 8080 on your host to port 80 on the container. So you can basically, this is useful when you want to troubleshoot. Yes, so it's useful when you want to troubleshoot. And I think there's something called Docker logs. Let me see, is it logs or log? Okay, yes, Docker logs. So basically it's just to check the logs of, remember when we ran the Nginx the previous time without using it in detached mode, we saw something like all of this. So you can still get all of this information by you running the command docker logs. So now I've showed you two commands that you can use to inspect what is going on with your container, which is docker inspect and docker logs. So now we have this container running. How do I stop this container? It's simple. Just use docker. I need the container ID. Let's do docker ps. So we use docker stop. Docker stop is basically to stop a running container. So docker stop and then the container ID. You paste the container ID. And now if we do docker ps, you can see that there's no running container. But if I do docker ps -a, you can see that it was exited 10 seconds ago. And this is the name, Romantic Bratin. So that's the same name there. And if I come to my browser and I refresh this, it's not going to give me, it's going to give me an error message because I have stopped the container. So yes, those are some of the useful commands. So now we've learned how to remove or stop a running container. So let's see if we can remove. I just want to prove something. So let's do docker images. Let's see if we can remove this Nginx image. The command to remove an image is docker rmi. I'm skipping a command. The command I'm skipping is the command to remove a container. So I'm skipping that. I'm going to the command to remove an image because I want to actually show something. So when I do rmi and I add Nginx, it will give me a response. Response from daemon config, unable to remove repository reference Nginx. Container this is using its reference. That is what I said. As long as you have a container that is currently using or that have used that image previously, you cannot be able to delete an image on your host unless you remove the container. And then the command to remove the container is docker rm. It's just as simple as that. So you paste, and then you can do it for, you don't have to do it individually, you can do it for all of the containers. So let me just remove all the containers, and then this last one. So we've removed all of them. So we can do docker ps -a. So we can see that there are no containers running or there are no previously run containers. So we can now go ahead and do docker rmi and then the name. So once I do that, you can see that it's untagged and it is deleted. So if I do docker images, so you can see that our Nginx image is no longer on our host. So we can always, pull it back or run it back whenever we want to. I just wanted to show you all of the commands. So I've covered docker image. I've covered about, up to 9 or 10 commands now. I've covered docker images, docker pull, docker run, docker ps, docker inspect, docker log, docker stop, docker rm, and docker rmi. So there's one more command there's one more flag I want to show you, and for me to do that we need a different type of image. So we'll go back and I want an Ubuntu image. So once you type an image, you'll see various versions of it. So, but one thing you should know that the official Docker image will always have it written on it. You'll see Docker official image. So once you don't see Docker official image written on it, it means that it's not like a Docker official image. So all of these other ones are like various versions of Ubuntu and all of that. You can see Ubuntu Kafka, Ubuntu Apache, Ubuntu Prometheus, but we are particular about the official Docker Ubuntu image. So I want to pull this particular image. Let me see if I can pull a lightweight version, but okay, no reason, no issues. So I'll just do docker pull Ubuntu, and once I do that, it will check my host if it's there. Since it's not there, it will go to Docker Hub to go and pull the image. So it's going to take a while. So I'm just going to also pause this video and I'll be back once the image is done pulling. I just want to show us something, and then we'll call it a wrap for today, and then tomorrow we'll go again. So I'm going to pause this video now. Once the image is done pulling, I'll show what I want to actually show you. And so I've successfully been able to pull the image. Now, what I want to drive at here is that the difference between Nginx and Ubuntu is Nginx is a service. Or we like call it a service or a software, something like that. While Ubuntu is an operating system. So the way we would approach Nginx is not the same way we would approach Ubuntu. Yes, the commands will be the same thing, but there's a flag I want to show you, and I'm going to run this image. Let me confirm. So we have Ubuntu. So docker run. I want to use -it. Now, what -it means is that we are running this image in an interactive mode, and we are going to, have a terminal for it. So let me run it, and you'll see what I'm talking about. So now you can see I'm in root at this particular when I say ID. So I'm no longer in Vetrax as Hundreds of DevOps. I'm running the image, but now it has opened a terminal for me. So it's basically as if I am running another Ubuntu OS inside my Ubuntu VM. If I do ls, you can see that I can do everything. If I can do everything that I would do on a normal Ubuntu VM. So I will do home. I can do ls Ubuntu. I can do cd to Ubuntu, and I can do cat /etc/ password. I can do everything, but this is an Ubuntu image, not my Ubuntu VM that I'm using for this particular session. So docker run -it, it just runs your image in an interactive mode, and it gives you it takes you into a terminal. There's a different command. There's another command for this, which is docker exec, but they do similar thing, but they work differently. Docker run usually is like you're starting the process. And you just want to go into it and do what you want to do. But docker exec works for a container that is already running. Let's say for example, now you have a running Nginx container now, and you want to go into the Nginx, you want to troubleshoot an issue with the Nginx. So you can actually go into that Nginx container and then do some things, do some configurations. So that way you just do docker exec into the Nginx container. You understand? So it's still docker exec -it. The -it means that you're running it in an interactive mode, basically. So if I want to come out of this, I just exit. So once I exit, I have my my normal Ubuntu back. So I hope I've been able to introduce us to this command. Basically, these are all of the commands we'll be working with. I don't think if there's any new command, maybe during the course of this phase, I would say, but I've listed close to 10 commands, and I think these are basically what the whole Docker ecosystem is built around. We pull an image. Okay, yes, there's one that I have not covered, which is Docker push. Yes, Docker push. Okay, 2, Docker push and Docker build. So tomorrow we'll probably look at Docker build, because we would be writing our own Docker file. We'll be introduced to Docker files, what Docker files is about, how it works, and then we'll also be writing our Docker file, which we will use to build our own custom image, and then most likely we're also going to be pushing the image to a remote repository. So I hope you've been able to learn one or two things today. Feel free to always share this video to anyone who is interested, like I said, or anyone that you want to get on board to learn DevOps. And we're just trying to make sure that we take everything step by step. We're not rushing, and that is why we decided that this whole session will run for 100 days, because we believe that we don't need to rush everything. We'll take it one step at a time, major thing is for you to get good understanding and for you to be confident when you want to go for that DevOps interview, or when you want to start working on your own project. You'll be confident and you know what you can do, and you can also defend whatever you're doing. So, and don't forget to subscribe to my channel. If you're really enjoying the videos I've been putting out so far, please subscribe to my channel, and most importantly, turn on your notification bell so that you get videos immediately I post. I try to post as much as possible or as often as possible so we can continue the 100 days trend. So tomorrow, like I said, we're going to write our Docker file. We'll see everything about Docker file and how to build a custom image and also how to run it. So I'll see you again tomorrow. Thank you. Cheers.